Start over or keep going?
Now,
Okay, so we're just going to discuss the basic principle of the isolated power panel, why it's here, and how to use it and so forth. So the number one thing to know about this system here is why it's in here. Why is this required for any facility which is having any type of invasive procedure or wet room, as you may call an OR or cath lab or endoscopy room, anything like that? These are required to be in there for one very important reason. The reason is this is wired differently from a regular electrical panel. And what makes it different is that you do not have a hot and neutral, which would normally be your two sources of power. Instead, you have transformers here at the bottom, which provide your power. 60 volts on both sides, which equals a regular power for here in the United States. And the ground is separate. The grounding is not connected at all to the transformers, which is the whole purpose of this being in the room. The reason that's important is when the ground is separated, it means any type of hazardous current or electricity is immediately grounded. And so it reduces quite drastically the possibility of that hazardous current traveling back through the wall, the wire in the room before being grounded, which it would be in a normal electrical panel, like in your home, office, or anywhere else. Because normally the ground is connected to your neutral. In this case, it's separate, and so you have to have this panel specially built in order to do that. So it immediately grounds any kind of hazardous, dangerous current. It doesn't allow that current to travel through the room before grounding and possibly shocking someone, but most important, possibly shocking a patient during surgery. So if you look at it on the inside here, there are two main components. This is your breaker box here, and this is your monitor. Your monitor basically is reading the leakage in the room constantly. It's getting a reading of exactly how much leakage is in the room at any given time. Now, what is leakage? What is current leakage or electrical leakage? Basically, any length of wire, no matter how long or small, when connected to electricity, has some amount of leakage. And so, for all the wire running through this room, back in here, it's going to have all that leakage. And this calculates exactly how much it is. Can you pause it for a second? So, right now, all of these wires are being measured for leakage, and this is your monitor to calculate that. Now, right now we're at a very low level of leakage, but as equipment is brought in and added, this number is going to go up and up and up. And so, at a certain point, it becomes a possible hazard, even though the chance of shock is very much reduced. It becomes a possible hazard if it goes above 5.0 milliamps. And so this monitor is reading for that, and it will alarm when it gets to that number. And I can demonstrate that for you. So if you hold your test button, it will go all the way up to 5.0, and then it will alarm. And the reason that this is important is because for all electronic devices being used in a hospital, electrical safety is of paramount importance. All devices are checked for electrical safety because in a hospital setting, you never want a patient to get any type of electrical leakage traveling through their body, through their heart, which could cause, as we all know, bodily harm to that patient. So this is reading that, and it's constantly monitoring exactly how much. Now, this does not affect your power. Power will be coming from here. This is your source of power. It's got a main breaker, and then all of these individual breakers control the outlets connected to it. So at the end of, when this is over, each outlet is going to have a list there of which breaker is for which outlet. That way you can trace them. Now, why does this have to alarm? And why is this necessary? Very important reason. Unlike a breaker box in your home or in your office or in other areas of the hospital, the power remains on at all times. If there is a device that has an electrical problem, and this goes into alarm, it's not going to trip the breaker. The breakers will not shut off for one very critical reason. They do not want critical medical devices to lose power. For example, an anesthesia machine, a ventilator, defibrillator, and we could go on and on. You don't want to lose power to a device that is providing life support to a patient. So the power remains on at all times. Unlike a GFCI, if, for example, in your home, you're running too much electricity to a breaker, say your microwave, your toaster, and your oven or whatever else, and it overloads a circuit, then the GFCI trips and it kills the power. And then you would automatically know that there's a problem because you no longer have power there. And you would go to the GFCI plug and turn it back on. And so that's how a GFCI works. It has a trip feature that shuts the power down. This does not. You don't want it to shut off. So the only way that the facility will know that a medical device may have a potential problem is when this alarms and goes off. Instead of losing power, it's going to alarm. So the alarm is critical. Please pay attention to the alarm. It's your only indicator that will tell you that there's an electrical problem in a room that needs to be addressed. Now keep in mind that because of the grounding being immediately grounded, there is not an immediate danger if it goes off. However, whatever is being done here in the room can be finished, and then facilities can come in and find out which device is causing the problem and fix it. So again, key points. You don't need to panic if it alarms, but do call someone if it does alarm, because it is telling you that a device connected to this panel has malfunction or has a circuit malfunction or shorting or whatever. And I'll give you a few examples. You wheel in a stretcher and you run over the power cord with the stretcher. Now you've broken the wire and the wire is exposed. It's going to look like a short and it's going to have leakage more than normal. It's going to alarm. Example number 2. You're working in the room and someone knocks over a bag of saline, and now it's poured all over the medical device. There's water in it, saline in it, and water and electricity don't mix very well, so the device is going to malfunction. Just 2 examples. There are many others, but those are some ways in which a device will malfunction and cause high leakage that needs to be fixed. So those are the key points to remember. Call facilities if it goes off, and don't ignore it. If it does go off, again, you can finish what you're doing, silence the monitor, and this will silence for up to 30 minutes. After 30 minutes, it will alarm again. Silence it again, another 30 minutes will go by. These monitors are self-calibrating and self-testing. It does a self-calibration every 6 hours. So you may see this CA. It simply means it's calibrating itself and it will resume normal function when it's finished. It doesn't take very long. Another key points to remember. These isolated power panels are meant for electronic devices being used in and near the patient for obvious reasons. And so all of the lighting, your booms, your monitors are connected to it. So are the red outlets in the room. I don't see any white outlets. That would be an alternative, maybe one, but we often tell facilities try to avoid using equipment that's not patient related in the room or in the isolated power. For example, radios, amplifiers, printers, computers. If you're going to use those things, use those on normal power, the white outlet, not the red outlets. Let's just do a brief overview on testing. These devices are required to be tested once a year, and both the monitor and the outlets in the room should be checked. That can be done by PG Lifelink. You can call the number there, or other third-party companies provide that service as well. But it is required to be tested once a year, and that test should be recorded and logged and kept for record keeping, just like all other medical devices which are checked either annually or semi-annually. Okay. Regarding the unit in here, trying to think of any other potential issues that may come up. Sometimes it may alarm and then shut off. We do see that from time to time. Keep this point in mind. Some devices are designed in a certain way that will trigger the alarm. I'll give you an example. An uninterrupted power supply has a large battery in it. And when plugged into power, charges the battery. If the battery is full, it dumps the power that it doesn't need. And this system senses that power dump to be leakage. And so it may go up and alarm and then come down and shut off. We see that all the time. It doesn't mean that there's anything wrong with the system. It simply means the device that was connected to it is triggering the alarm. So please keep in mind, if it alarms 99% of the time, the reason it's alarming is because of a device that has been connected to it that is causing it to alarm. And that device, or those devices, should be checked to see and find out why it's triggering the alarm. Okay? So overall, this is a very important safety device, safety feature. It's here for a very important reason, to prevent shock hazard, which is critical in a hospital setting, especially one where surgeries are taking place. Number two, the monitor is very important to not ignore when it goes off, but also keep in mind it does not affect your power. Power will not be shut off due to the monitor or a device which may have a problem. And finally, it must be tested once a year. That being said, enjoy using the isolated power.